There is an interesting question of parabola. And as you can see clearly, y minus x 3x whole square equals y minus x. So it represents some parabola. Clearly it's not a standard parabola, which is y square equals 4ax type. Neither it is shifted in any ways, right? Because if we have shifted parabola, we'll have y minus beta whole square equals 4a into x minus alpha. So there is no xy term. Now clearly we have xy term. So presence of xy term represents the parabola is inclined to the axis, something like this maybe. And what is the significance of coefficient of x and coefficient of y? The parabola is shifted as well. Okay, so it's oriented in some way, we don't care, as well as it is shifted. So it's a general case of parabola. Question is, if vertex is alpha comma beta, for this parabola we need to find alpha by beta. Now one way of solving this is you can use like translation and rotation of axis to convert this parabola into a standard form. Y square equals 4x. From there you can find the vertex and go back in the rotation or translated world to get the answer. But what I'm going to do is a very interesting and conceptual game that will play over here. So what I'm going to do is a very conceptual game that's I'm gonna play over here. And here we go. We know, like, if we have axis of this general parabola, it will definitely be a line which is passing through vertex P, right? Now in terms of quadratic expression, what is the significance of parabola when you solve with a line? So let's say if I have got a general line y equal to mx plus c, because to start with I don't know. If I solve this expression, which is a second degree expression, with y equal to mx plus c, so let me put mx plus c minus 3x. So I'm solving parabola with a line, right? Equals mx plus c minus x. So clearly I'm going to get three conditions, right? So it's a quadratic in x. So it's x square plus something, course something x square plus something x plus something equals nothing. So depending upon restriction of m and c, it can give either two real roots, x1 and x2, which is distinct, or it can give equal roots, or it can give maybe both root as imaginary, so they are not real, right? Which is basically if d is greater than 0, d equals 0, and d less than 0. In any case, if d greater than 0, so basically the situation that I'll get is the parabola is being intersected by the line y equals mx plus c at two distinct points. For d equal to 0, we have a tangents because both root has become same, so we have exhausted both root here as a point of tangencies. Here x1 equals x2. Significance of d less than 0 is parabola is not intersecting the line. Okay, now what kind of situation we have here for a line which is basically axis of parabola? So clearly it is intersecting at one point, so it cannot be case number 1, it cannot be case number 3 for sure. Now try to understand whether it's case number 2 or it's something different from this. Clearly it's not even case number 2, because there is a difference between touching at a point and cutting a line exactly at a single point. What difference we have? Here in this case, the equations that we'll get is x minus something whole square equals 0 kind of, or maybe something 5 or 6. So we are getting two equal values of x. Here we are getting exactly one value, but where is the other root? This is not a repeated root, okay? It's not a repeated root. So it's very interesting question. Like a line is cutting parabola, but it's neither of this situation. How it can happen? Because a quadratic expression, second degree expression in a line, will have only three possibilities. So here for the first time we are getting other possibilities. So it is d greater than 0, clearly no. It's d less than 0, it feels clearly no. So what about d? Is this d equal to 0? Clearly no, because the roots are equal. So d equals 0 will be the tangential case. The axis cannot be tangent to this. So basically the case here is one of the root you are getting, let's say alpha, and the other root is at infinity. Let me little bit justify this situation. So let's say if you have equation x square plus x plus 1 equals x square. Although directly you can't tell it's a quadratic, but for the time being, if I try to assume it is a quadratic because of presence of x square, So if I'll cancel this, we'll have one of the answer as -1. What about the other root? The other root I can tell x to be infinity. So if I want to believe like still is a quadratic, I can still tell two roots. One is -1, other is infinity. Because when x is infinity, this both will go to infinity. In that sense, I'm telling, okay, one root has go to infinite and other root is -1. To in quadratic equation, suppose if we have m minus 2 into x square plus x plus 1 equals 0. So let's say if this is a quadratic expression, for what value of m, we'll have one root to be, let's say, -1, other will be infinity. One root finite. So let's say we have this quadratic expression, and your question is for what value of m, one root of this quadratic expression goes to infinity and the other root is finite. So clearly one root will be simply get lost if m is exactly 2, because if m is exactly 2, no more you have quadratic, right? So just the root that will get is x equals -1. So I can tell the other root get lost or it has went to infinity. Okay. Now again you might wonder like how I'm telling like other root is going to infinity, because when it is 0 into infinity kind, although it's exact 0, but still I can tell it's 0 into infinity is tending towards 0 by 0, so it can be anything. Okay, so this is a philosophical way of telling like when you have exactly one solution with a line and it's not repeated, neither like cutting it or not touching it, then one root is finite and the root is infinity, and that's exactly the case. So we want the value of m in such a way such that the x square coefficient becomes 0. So if x square coefficient becomes 0, the only way where x square will be produced is as long as x terms is alive there. Okay, as long as x term is alive, its square will give x square. So the way to kill it is you kill the x term, that can be killed with m equals 3. Okay, hence we know now the axis equation must be y equals mx plus c, which is given by y equals 3x plus c. As long as m is anything which is not 3, if m is not 3, either we'll have this case or this case or this case. In any case, that's not allowed. So the conclusion is we must have the axis slope as 3 over here. And now with this, we already know the slope at the vertex to the parabola. Right, so let's say that point is alpha comma beta. We know the slope of tangent at vertex, so that you can directly differentiate that equation. So y dash minus 3 equals y dash minus 1. Implies the slope at that point, since the para satisfy this, so y minus alpha comma beta will, since alpha comma beta lies in the parabola, so beta minus 3 alpha whole square is gonna be beta minus alpha, right? So if you put this to beta minus 3 alpha into slope at that point divided by dx, so slope of tangent should be minus 1 by 3. So let's keep minus 1 by 3 minus 3 equals minus 1 by 3 minus 1. That gives me 2 into beta minus 3 alpha equals minus 4 by 3 divided by minus 10 by 3. We have 2 by 5. 2 cancels, so beta minus 3 alpha equals 1 by 5. Okay, so we can subtract this equation and that will give 2 alpha is minus 4 by 25 implies alpha equals minus 2 by 25. Now once you know alpha, you can put in either of these equations and that gives beta equals minus 1 by 25. So vertex is known, hence alpha beta equals